Hello everyone, my name is Ore Adenikinju, and today I'll be providing an in-depth data analysis to hotel booking information and whether we are able to predict the booking cancellation. The dataset that I utilized for this project was sourced from Kaggle, and it contains booking information derived from a city hotel and a resort hotel, both located in Portugal. The dataset contains around 120 case samples and consists of 32 features, 12 of which are categorical features and 20 which are numerical. This project can prove useful to hotel companies who would like to optimize resource planning, maximize potential profits, improve booking cancellation policies, and define better overbooking tactics. In order to properly train and test the various models that I will be using for prediction, it was necessary to initially process the given data. I started off by separating the categorical and numerical features from each other, then removed other features which I deemed irrelevant or unhelpful. I noticed that the agent and company features identified the exact entity that created the hotel booking if it wasn't made by the customer themselves. However, I thought it was more appropriate to instead only track whether a travel agency or company made the hotel booking for the customer rather than what agency or company it was. Thus, I created two new binary features which did exactly that and dropped the original two. Additionally, I created another feature which tracked whether the assigned room was the same as the room that the customer originally reserved, as I believed that this could also prove beneficial for the prediction phase. I then dropped the reserved room type feature, but decided to keep the assigned room type feature because the type of room itself can also play a part in why the customer decided to cancel their booking. I calculated the Pearson correlation and created a heat map as well as an ordered list in order to see the correlations between the features themselves and between the features in the target label. I decided to drop any feature with less than a 0.01 correlation value. I then used log normalization on numerical features that had a high variance, encoded each one of the classes of the categorical features, concatenated the process categorical and numerical features, and finally split the entire process dataset into training and testing data. I used a 0.7 to 0.3 split, resulting in the split you see at the bottom of the slide. Here's a little visual representation of how balanced the dataset is. As you can see, about 1/3 of the data are bookings which are canceled. Now let's move on to the experiment. I used 6 different models as listed in the slide that were capable of binary classification, mainly in order to compare the results between each other and determine the best model. I was met with quite the surprise when I discovered that all of the models, with the exception of KNN, had a 100% accuracy score even without any cross-validation practices. I tracked the precision, recall, F1 score, and accuracy of each model. Even with such successful models, I decided to try to improve the KNN model as much as possible in order for it to match the others. In this effort, I used k-fold cross-validation and attempted to find the best hyperparameter, but found that the results were even worse than those without cross-validation at all. I also attempted using Monte Carlo cross-validation, but ended up receiving the best accuracy when the hyperparameter was only at 1. This accuracy score was the exact same as the one I received without any cross-validation methods, demonstrating that the Monte Carlo cross-validation was not that effective. I also did some relevant data analysis and created a bar graph which shows the percentage of cancellations per month separated by the type of hotel. I found that the city hotel maintained a consistent booking cancellation ratio year-round at around 40%, while the resort hotel has its highest cancellations around the middle of the year and its lowest around the beginning and the end of the year. This makes sense considering the type of hotel each one is. We can also apply what we learned from the data analysis to the real world and accomplish some of the motivations mentioned at the start. Some ideas could be to scale booking prices or cancellation fees according to patterns of cancellation throughout the year, or have more of a tendency to overbook during months where cancellations are high, or lastly even derive a formula that can help with efficient resource planning. Upon some further research, it turns out that my prediction models are very comparable to others that I found on Kaggle, but some future plans or improvements that I could set out to do is more in-depth feature analysis to see what exactly causes booking cancellations or what can be done to prevent future booking cancellations. Also, since the accuracy of the models are so high, it could be worth to get additional data from hotels all around the world in order to test whether these models are more general or specific. Thank you.